we plan our lives around rain. We always want to know when and where and how much. Not just for our weekend plans, but for how we make decisions about our safety and transportation, our economy, or our livelihoods. So, how do we measure rain? Well, we can set out a rain gauge, like this one, and it measures the amount of rain that falls over time. The problem with this is that it only measures rain in one very small spot. In fact, if you took all of the rain gauges in the world, packed them together, they would fit into 2 basketball courts. Now, we can cover more ground if we use radar. Radar sends out a signal, and it measures how much of that signal is scattered by rain or snow. But radars are only available in certain parts of the world, and many countries just don't have access to that technology. And that's just on land. Think about how we're going to measure rain over all of the world's oceans. Look, the point is it's impossible to cover the entire Earth with enough instruments that are going to give us accurate precipitation rates for the whole globe. So, we have to think bigger and higher. Instead of having a patchy network of rain gauges and radars, we could have a whole constellation of satellites looking down at the Earth, measuring things like falling rain, snow, and even ice. The Global Precipitation Measurement Mission, or GPM, is going to do that, and it's going to give us precipitation rates for the whole globe every 3 hours. Now, GPM is going to cover it all, from land and oceans, from the tropics to the edge of the poles, over mountains and valleys, from our farmland to our cities and towns. We're going to need more than a perspective on the ground if we're going to look at precipitation from a truly global standpoint. And GPM is just the mission that's going to give us that big picture.